Steelpaint is a German manufacturer specialized in single-pack moisture-cured polyurethanes. This presentation concerns the application of our PU Zinc in cargo holds of ore carriers to prevent major steel renewal. In 2008, Steelpaint was invited to participate in a full-scale test on board of Sophie Oldendorff, a Panamax bulk carrier owned by Oldendorff Carriers. The purpose of the test was to find the most suitable coating system for the cargo holds. A different coating system was applied in each hold. Steelpaint was appointed hold number 3, which is also used as a ballast base and therefore the biggest challenge. The system applied was 2 times 100 microns of PU zinc. The other holds were all coated with glass flake reinforced epoxy coatings at DFTs averaging from 600 to 1200 microns. After 6 months, all holds were evaluated. Hold number 3 was the only one in excellent condition. All others showed the usual signs of breakdown. During the next dry docking, after 2.5 years, hold number 3 only had some minor spot damages, 5%. All other holds had to be fully staged and blasted again, 50 to 75%. They were all repainted with Steelpaint's PU Zinc. Since then, Oldendorff has gradually changed the coating system in the cargo holds of their own fleet to the PU Zinc. The next slides are about an inspection in cargo hold number 4 on board E. Oldendorff. In 2013, Oldendorff Carriers launched an extensive new building program. In order to decide whether to apply the PU Zinc in the cargo holds during new building, an inspection was conducted on board E. Oldendorff, a Panamax self-unloader here seen in the middle. Cargo hold number 4 was the only one available due to loading operations. At the time of the inspection, the PU Zinc had been in service approximately 1.5 years with frequent loading and unloading activities due to the short trading pattern of the vessel, Persian Gulf only. This is an overall view. Excellent condition of the PU Zinc after 1.5 years of trading iron ore. Here you see a cross test showing excellent adhesion of the PU Zinc. A close-up view of some damages. There seems to be some corrosion at first sight. However, the rust staining is caused by cargo iron ore residue. It is merely superficial. When removed by scraping or wire brushing, the metallic action of the zinc becomes visible immediately. The average film thickness on the lower hopper is approximately 150 microns. Even in the heavily damaged areas, there is still plenty of PU Zinc left on the substrate. In this area, the remaining dry film thickness is 102 microns, offering corrosion protection. No loss of steel thickness. The conclusion is that after 1.5 years service, there is 0% corrosion. Following the successful inspection on board E. Oldendorff, it was decided to select the PU Zinc system for a series of new buildings in China. 9 39,000 deadweight bulkers at Nanjing, Jinling. two 94,000 deadweight bulkers at New Yangjian. Coating system 2 times 100 microns of PU zinc. For the sides, upper and lower hoppers in all cargo holds. At the same time, we started a test program on board VLOC Berge Berea of Berge Bulk. The purpose of this test was to see if the PU zinc would hold up to the impact and abrasion of the cargo, grab and bulldozer. Not only on the lower hopper and sides, but also on the tank tops. The total area of the test is about 100 square meters in the center and partly on the lower hopper, in hold number 6. The surface preparation was slurry blasting, SA2, ginger to anise number 7. Coating system 2 times 100 microns PU zinc. In one area we tried 3 times 100 microns of zinc to see if there would be any difference. This is the first coat of PU zinc reddish gray at a film thickness of 108 microns. Application of the second coat, PU zinc gray. Here we see a cross test showing excellent adhesion between the PU zinc and the substrate and itself. The results after the first and second cargo round trip looked very promising. We were seeing that even in the heaviest damages there was still enough zinc left to offer protection. There were only very few areas where the PU zinc was totally gone. Around these spots the zinc will offer cathodic protection to prevent corrosion. Here we see the unloading in progress. The blue square shows the location of the main test area. The crosscut shows that the adhesion is still excellent. The overall condition is very good. These pictures show the results after the second round trip. The average total film thickness is around 200 microns. Even in the damaged areas we can still find zinc. Here we see that there are still 20 microns of zinc left on the substrate. Here we see that the dry film thickness is 169 microns. And after scraping with a coin you can see the metallic action of the zinc quite clearly. After the promising results of the test on board Berge Berea, it was decided to do a full Capesize vessel. This was on board Berge Matterhorn, a 170,000 ton deadweight Capesize Bulker owned by Berge Bulk. During a dry docking in Shenzhen Julian shipyard in China, April 2014. The tank top after high pressure fresh water washing. Surface preparation, drip blasting SA2. On the lower hopper, the old epoxy coatings were not completely removed. Application of the single pack, more secured polyurethane, zinc reddish gray at 100 microns. Application of the second coat, PU zinc gray. Here we see the final result. The total DFT is between 208 and 250 microns. After 9 months service, the results were checked in Taichung, Taiwan. Unloading in progress. This is an overview of hold number 5. No corrosion. DFT varying from 166 to 220 microns. A close-up of a new bottom plate. Close-up of an old plate with heavy pitting. This is a close-up of the lower hopper showing very few damages. A cross-cut test showing that the adhesion is still excellent. Inspection by microscope showing that not one of these scratches goes to bare metal. The following videos were taken during an inspection in Rotterdam after 1.5 year service life of the PU Zinc.
Okay, we're now in hole number 8. Number 8 has not been repaired by the crew yet, and we're going to locate the areas which need attention. Here you can see the bulldozer, which is scraping over the bottom, and it will hit the areas that are sticking out higher than the rest of the areas most. For example, if you see this, the grab here, you can see here this area following, and this is exactly on top of one of the frames in the double bottom. So basically we can say that all the frames of here in of the double bottom structure need some attention. You can see there's no corrosion in most places because in a lot of the areas there's still zinc. Even here where the bulldozer hit it pretty bad, there's still 154, 246, 175, and obviously in there are some small areas where the thickness will be very low, but because the zinc, the surrounding zinc is offering cathodic protection, these areas are not corroded yet.